How do we find asymptotes of irrational functions? First of all, let's define an asymptote. An asymptote is an imaginary line that is approached by a curve on a graph but never touches it. And we do not have to draw the asymptote lines in. Sometimes we just use dotted lines to show that they are there. And rational functions can have 3 types of asymptotes. This video is not about rational functions, but I did do a video on rational functions, and I'll put a link to that video at the end of this YouTube. We can have horizontal asymptote, or we can have a vertical asymptote. And the third type is called an oblique asymptote. Sometimes I call it a slanted line, but oblique is the proper name. And sometimes there are no asymptotes. In this video, I will only deal with the horizontal asymptote and the vertical asymptote. I'll leave the oblique asymptote to another video. So the question is, how do we identify what type of asymptote a rational number can have? It may be that it has 2 different types of asymptotes as well. The method to find horizontal asymptote changes based on the degrees of the polynomial. For example, the polynomial 3x minus 2 will have a degree 1 because its exponent is 1. And so the highest exponent in 2x plus 3x squared is 2. So the degree will be 2, and so on. Now, as you know, a rational function has 2 polynomials, one in the numerator and one in the denominator. Now, there are 3 rules because there are 3 cases in finding the horizontal asymptote. So I'll start with case 1. So in case 1, I would like to show you visually that the degree of the numerator here is less than the degree of the denominator. For example, I might have 3x squared plus 2x over x cubed plus 1. And you can see that the 2 is less than 3. If this is the case, then your horizontal asymptote will always be y is equal to 0. For example, this particular rational function, x plus 1 over x squared minus 1, with a degree 1 in the numerator and 2 in the denominator, and you can see that the asymptote is y is equal to 0 here in yellow. Okay, let's go to case 2, where the numerator degree is the same as the denominator degree. For example, such as x squared plus 1 over 5x squared plus 1. Here the degree is 2 and the degree in the denominator is also 2. Here the asymptotes are found by the leading coefficient in the numerator over the leading coefficient in the denominator. So our horizontal asymptote will be y is equal to 1 over 5, or you could say 0.2. So what will the asymptote look like? It will be a line through 0.2. And the line is called y is equal to 0.2. Now let's have a look at case 3. This time the degree of the numerator is larger than the degree of the denominator. Let's say x squared plus 1 over x minus 1. Here you can see that the degree here is 2 and the degree of the denominator is just 1. And in this case, there is no horizontal asymptote. Now I'd like to talk about vertical asymptotes. To find the vertical asymptotes of irrational functions, we need to simplify the polynomials to the lowest terms. And then we set the denominator equal to 0 and solve for x. Let me show you what I mean. I'll have to give you a number of examples. So there are 3 steps. So the first step is to factor the numerator and the denominator if you can. And step 2 is to cancel any factors from the numerator and the denominator to simplify. And finally, the last step is to set the denominator to 0. Let's look at an example. We have fx, x minus 1 over x squared plus 5x plus 6. So you want to first of all factor the numerator, which you can't, so we'll leave it alone. And you want to cancel the denominator into 2 linear factors that will always start with x. So we'll do that, x. And this will be x plus 2 and x plus 3, because 2 times 3, it will give you the 6, and 2 plus 3 will give you a 5. Now you can see that none of these can be cancelled down, because step 2 says cancel any factors. Now since we can't cancel any of these factors, we just need to leave them like this. And now we're going to go to the third step. With the third step says set the denominator to 0. So the denominator is x plus 2 and x plus 3, and we're going to set that to 0. And through our null factor, we know that x plus 2 therefore must be equal to 0, or x plus 3 must be equal to 0. If that is the case, then x must be equal to negative 2, and in this case x will be equal to negative 3. Now these two will be our vertical asymptotes. So let me show you what the graph of this looks like. We have 2 variants of this. One is already factorized and one is not. And now we know that x plus 2, this is where we find the vertical asymptote, and I will try and draw it in for you. There's x is equal to minus 2 and x is equal to minus 3. I left this function in 2 different forms because if you look at this particular form over here, we can use this to also find the horizontal asymptotes. And the rule is here to look at the degrees. And the degree in the numerator is 1 and the degree in the denominator is 2. So the numerator is smaller degree than the denominator, and this indicates that there must be an asymptote where y is equal to 0. And so we also have a horizontal asymptote, which is going to be y is equal to 0, and you can see it in here on the yellow line. So let's have a look at an example 2 quickly. We can factorize the top because it's just a quadratic, and then we look at the bottom. Now that's just a different form of quadratic. It's called difference of 2 squares. So we factorize it into x minus 2x plus 2. Now the second part of it is we need to cancel, so that's the next step, and we can see that we can cancel x minus 2 and x minus 2, and we're left with, in step 3 we look at the denominator and we set it to 0. So x plus 2 is equal to 0 means that x is equal to minus 2 is going to be our vertical asymptote. And there's also a horizontal asymptote because the degree here is 2 and the degree here is 2, and we use the fact that the coefficient therefore is 1 and 1. So y is going to be equal to 1 is going to be our horizontal asymptote. And we can check this on the graph. X minus 2 is going to be our vertical asymptote. And y is equal to 1 is our horizontal asymptote. There's one very quick example that I want to do with you, and this is because this particular function does not have any vertical asymptotes, and I want to show you why. So we've got here in the numerator a constant, and in which is a polynomial. Okay, we know that that's the definition of a polynomial. And in the denominator, we've got a quadratic. Now, if we want to find the vertical asymptotes, remember, first of all, we try to factorize this. We can't factorize the bottom, we can't factorize the top. So number 2 is cancelling the factors. We cannot cancel the factors because there are no cancels to factors. So finally, the third step is to make the denominator equal to 0. So let's make the denominator equal to 0, and that means that this will be, if it makes to 0, so that means that x squared is equal to minus 1, which would mean that x is equal to plus or minus the root of minus 1. So there are no vertical asymptotes. And that's okay. You don't have to always have vertical asymptotes. Are there any horizontal asymptotes? The numerator degree is less than the denominator degree. That means that there must be a y equals to 0 asymptote. So y is equal to 0 is going to be the horizontal asymptote. So let me just show you what this looks like. So this is the graph of the function 4 over x squared plus 1. And you can see that it doesn't have any vertical asymptote, but the horizontal asymptote is right below here, drawn by the yellow line. Now there are many examples which I would like to go through, but I don't have the time over here. But if you are concerned with any particular function and you're having a hard time finding the vertical and the horizontal asymptotes, please let me know in the comments, and I will get the answer to you ASAP. And please subscribe to this channel and press the thumbs up.